Okay, so now going back to the original formula. So we have computed the incoming flux. We have multiplied this incoming flux with the Fresnel term. Okay, and then we have multiplied this with the geometry term. With this, we get we compute the outgoing flux. Okay, so now if you clean up everything, now we have some light being emitted along this WO direction. Okay, so and the total flux in that light is represented by this formula. So how do we compute the outgoing gradients? Now again, remember this formula. To compute the outgoing gradients, we must divide this flux by the projected area of the surface, okay, along the WO direction, and also by the solid angle. So we will take this. We will do the following. We will say this is equal to G WI WO F theta prime. Okay, and what did we write for this one? This flux was equal to, actually going back to that, we wrote Li, okay, we had A, the area of each facet, cos theta prime, okay, cos theta prime, what do we have? We had d alpha, okay, and then we had dWh. I know that it's getting a little bit confusing here. dWh, dA, okay, and dWi. Okay, there are a lot of differential terms here. Remember, we come to this point not instantly, right? So we have been, so this was our incoming flux. So we first multiplied this with this, then we multiplied with this to obtain this part. Okay, so we multiplied here and so on. So we have derived this, where this comes from. So this is the incoming flux. We are going to divide the incoming flux by this thing right here. So how are we going to obtain this? So we are going to have this surface, basically the projected area of this surface along the outgoing direction. So this is equal to dA, okay, and this is important, cos. So how much, what is the projected area of this surface along the outgoing direction? Now this time we are going to use the real surface normal, okay. So this is basically cos, what is this angle here? Cos phi, I think, right? Cos phi. Okay, so this angle, cos phi, and then dWo. Okay, so this is the outgoing gradients. Now there is one simplification possible here, right? So we can clean this part and this part, but another simplification is possible because of a rule that we have learned earlier. In the first couple of videos I have mentioned that there's a relationship. So please remember this relationship. What did we say? dWh was equal to dWo divided by 4 cosine theta prime. Okay, so it's not clear, right? So this is 4 cosine theta prime. So please remember this derivation. Okay, so instead of dWh, we will write this. So I will write here dWh, I will write dWo, and here I will write 4, okay, and then cosine theta prime. Okay, we add that. So now we have a couple more simplifications possible. This is gone, this is gone, okay. This is also gone, and this is also gone. Now, one thing we can do is we can also remember d alpha. This is the distribution, right? So it's we had a normalization term. So you could also embed this. You can take this A here, which is the microfacet area. You can embed it into the B term here. Okay, so remember this d alpha was equal to B times e to the power minus c square alpha square. Okay, so A is just another constant, right? So you could actually embed this in this term, inside this term. So I'm also going to remove this one.